Let's solve different questions on isomerism question. And it's going to be based on the first video we have done. Right? In the first video, I explained what is called isomerism, the different type of isomerism, and what is chain, positional, and what functional group isomerism. So we are going to look at some example possible questions that like setting under that aspect. If you have not watched the first video, I'll advise you by the end of this video, you should go check out that first video. So let's start this first one. You see that which of the following pairs of compounds are chain isomerism? They say what? Chain isomers. Chain isomers. Now, what I want to explain here. Now, in the last class, we talked about what's called chain isomers or chain isomerism. Here we have what positional what isomerism. We have what called functional group isomerism. The functional group of isomerism. Now, what is chain isomerism here? Chain isomerism, they only differs in the what arrangement of atoms along the chain, right? It does not have any specific what functional group here. Example is what is the alkane. It's okay. So if you're talking about any isomers that involve alkane, it's called chain what isomerism. Just so we talk about when the question is given to you and they say which of these is what is chain isomerism, what your mind should go or where your eye should go is what alkane. Is there an alkane? If there's an alkane, fine. That is the answer here. But understand that two or more compounds, they can only be isomers of each other when they have the same molecular formula. So one of the criteria for two or more compounds to have to be isomers is they have what the same molecular formula. Right there, they have what the same molecular formula. The same molecular formula here, but different structure, right? So let me guys look at here. Here we have CH3. We have this guy CH3, CH2, CH2, CH3, and CH3, CH3, and what CH3. The first one to understand here, the first one to ask yourself, these two here, do they have the same molecular formula? That is the first thing to ask yourself. Do they have the same molecular formula? And the question is yes. Why? How do they have the same molecular formula? How do you know if they have the same molecular formula? Yeah. Let's count numbers of carbon atom here. Here we have 1, 2, 3, 4. So you have C4, right? 1, 2, 3, 4, right? Now let's count numbers of hydrogen. 3, 5, 7, 10. Here we have 10. It's okay. So the molecular formula of this guy is C4H10. What about this one here? 1, 2, 3, 4. 4 carbon atom, right? C4. How many hydrogen? Here we have 3 plus 3 plus 3 plus 1, which is what is 10. So these two have the same molecular formula, right? They have what the same molecular formula. But did they have any functional group here? There's no functional group here. All are alkane. The two of them are what alkane. It's okay. If you look at the name of this guy here, this guy is called butane. This guy is called butane. It's called what? N-butane. It's called what? Butane. This guy is called butane. Just a 1, 2, 3, 4. Now, why this guy is called 2-methyl-propane? 2-methyl-propane. It's okay. 2-methyl-propane. So here we have N-butane, 2-methyl-propane. They don't have the same structure. How do you know if they don't have the same structure here? They don't have the same isomer. So N-butane, 2-methyl-propane are isomers. But what type of isomers? They are called chain isomers. Chain. Now the main reason why they are called chain isomers is that here we have how many carbon atoms do you have in what? Here, the straight chain. Here we just have 4. There's no branch chain, right? But here it's still 4 carbon atoms here, but it's branch. So it's called chain isomerism. They have the same molecular formula, but they have the same structure. The reason is because they differ in the arrangement of the carbons. That's what the first one. So the first one is what is the answer because of chain isomerism. But we still have option B, option C, and option D. So let's look at each of them here. Here we have this guy, and here we have this guy here. Now, what is the name of this guy here? This guy is what is a what? There's a double bond here, and there's a double bond here, right? The name of this compound here. Therefore, you have to ask yourself: do they have the same molecular formula? That's the question you need to ask yourself before you can answer. Before you can start asking any question. You need to therefore ask yourself: do they have the same molecular formula? Now, how many carbons do you have here? 1, 2, 3, 4. C4H, right? How many hydrogen? 2 plus 1, 3 plus 3, 6 plus 2, 8. C4H, 8, right? But here, how many do you have here? 1, 2, 3, 4. C4. How many hydrogen? It's still what? 3 plus 3, 6 plus 1 plus 1, which is what is 8. Now, they have the same molecular formula. Just they have the same molecular formula here. So it's not that they can be isomers of each other. Now, but if you look at it very well, straight chain, number 1. But here's what is the functional group here. The double bond is the carbon number 1. The double bond is the carbon number 1. Here, the double bond is the carbon number 2. Do you understand? So the name of this guy, the first one is called 1-butene. Is 1-butene. That is what the first one, 1-butene. One here is 2-butene. Now let me ask you here, what type of isomers is this? Is it chain? Is it position or functional? Let me ask you here. Now the answer is called positional isomerism. Positional what? Isomerism. It's okay. Now what is positional isomerism? In positional isomerism here, they have the same molecular formula. They have the same functional group, but differs in the position of the functional group. Just so what we're saying this guy here is that the structure look the same, but what happens is that this double bond here is a carbon number 1, this double bond here is a carbon number 2, so they differ in the position of both double bond. Just and double bond is what is functional group. So when we talk about chain isomerism here, the first thing we want to understand here is that they should have the same molecular formula number 1. They should have the same functional group number 2. The only difference is that the difference in the functional group should be different. So it's called positional isomerism. They're talking about chain isomerism. So this one is correct, this one is not correct. Do you understand? Let's look at this guy too. This guy also what? Or this guy also what? Positional isomerism. Why? Because here we have OH, here we have OH. The OH is our carbon number 1. Why is our carbon number 2? This is called positional. Positional what? Here it's called positional. Positional isomerism. It's okay, positional what? Isomerism. Do you understand? So this one is what? Chain, so is what? Positional. This one is what? Is positional. Which is the answer here. Let's look at what the D part. Right? Here we have this one here. Now, if you check very well, they have the same molecular formula here, because how many carbon atoms do you have here? 1, 2, 3. C3H. How many hydrogen? 5, 6, 7. No. 8. Here we have 8 O. Just that. If you check very well, now the two of them have the same molecular formula, because here C3H8 oxygen. The same thing here. C3, here we have C 1, 2, 3, C3H 2, 3 plus 2 plus 2 is what? 5, 7, 8. 8, they're also here. Just that. So two of them have the same molecular formula. Of course, they are what? Isomers. But if you check very well, the functional group are not the same. This guy here, you are seeing, this compound here is what? Is an ether. Ether functional group. Ether functional group here. Just like this one is called ether. Why is it called alkanol? So when two isomers have different functional group, they are called functional group isomerism. Functional group isomerism. Functional group what? Isomerism. That is the answer. The answer is what? Functional group what? Isomerism. So we have done what the first one here, right? If you understand the first thing I've done here, please let me share that you understand. And if you don't subscribe, please kindly subscribe. Share this video to your friends, right? Let's look at what the second question. So look at our question 2 and our question 3. Please pay close attention here. So they say how many chain isomers can be found in C5H10, right? Therefore, you need to confirm this guy here if it's an alkane, right? Or if it's an alkene or what? Alkyne. If you check very well, C5H10, C5H12 should be an alkene, right? Because how do you know alkane? Remember here we have alkane, alkene, and what? Alkyne. It's okay. And each of them have their own general what molecular formula because it's an hydrocarbon, right? So the hydrocarbon can either be alkane, alkene, what, and alkyne, right? Now, remember each of them have their general molecular what formula, which is what this one is what CnH2n plus 2, right? Here we have what CnH2n plus. We are CnH2n, and here we have what CnH2n minus 2. This that. Now, if you ask a question and it's an alkene, they're asking you how many isomers can be found here. The thing is that if it's an alkane, you don't need to draw the numbers of isomers, although you can draw the numbers of isomers, which I'm going to explain to you. But there's a formula you can use to apply to get the numbers of isomers. If it's what? If it's an alkane. You understand? Remember, alkane do not have a double bond, not be a triple bond, it only have a single bond, right? So you need to ask yourself, does this correspond to this? Does this correspond to this? And does this correspond to this? You need to ask yourself, right? Because they can give you anything at all. So you need to ask yourself, does this correspond to this? Does this correspond to this? And does this correspond to this, right? Where's my n? My n means what? Numbers of carbon. N equals to what? Numbers of carbon. Numbers of what? Of carbon. So if you look at this one here, C5, right? That is my numbers of carbon here is 5. That is my n is equals to what? 5, right? So if you should put this 5 at this point here, let's confirm if it's an alkane. If you should put it here, if you look at here, we have CnH2n plus 2. If you want to put 5 there, go to do what? C5H25 plus 2, right? We go to do what? C5H2 times 5 is what? Is 10 plus 2 is what? Is 12. So is what is an alkane. Just now. So when a question is being given to you like this, you have to confirm if it's an alkane or not. So if it's an alkane, we have a simple formula to use to get isomers. Just what is the simple formula here? In the first class, I gave you the formula, right? But now let me give it to you again. Numbers of isomers is equal to what? 2n minus 4 plus 1. It's okay. 2 goes for n minus 4 plus 1, right? So now since my n is equal to 5 here, so my n is equal to what? 5. What will happen here? If you put 5 here, so numbers of isomers is equal to what? 2, 5 minus 4 plus 1. So 5 minus 4 is what? Is 1. So let it be what? 2 less than 1, which is what? Is 2 plus 1 is going to be what? 3. So the number of isomers for C5H12 is what? Is 3. So look at something here. I don't want this going to be too lengthy, right? In the first video, I drew the numbers of isomers. Just now you need to confirm if this guy is an alkane. For example, here we have C8H18 is an alkane, right? They should not ask here, how do you know it's an alkane? Plug this one here, right? If you plug from here, if you plug this one, if you plug this guy at this point here, like if you plug this guy, my n equals to what? Or 8 here, so it's C8H28 plus 2. You see that? So going to be C8H16 plus 2 is 18. So it corresponds, right? So if they should ask here, how many isomers can you get from here? You just simply apply the formula here. So look at what this question here. Now this question is a little bit trickish. So please pay close attention. They're asking here, the type of isomerism in this compound and cyclobutane, right? Remember, I told you one thing. Before you can start asking, before you can start solving any question or giving answer to any question, you need to ask yourself, did they have the same molecular formula? Now, if they don't have the same molecular formula, yeah, automatically that question is wrong. Just but if they have the same molecular formula, they cannot confirm if it is what positional, chain, or functional group what isomerism. Just or any other type of isomerism. So let's confirm. If you look at this guy here, this guy called one butene. It's okay, one butene. Why is it one butene? 1, 2, 3, 4, right? And to have a double bond. This is that. So how many carbon atoms do you have here? 1, 2, 3, 4. 4. So you have C4H. The number of hydrogen here is what is 8. So 2 plus 1 plus 2 plus 3 making 8. So you have C4H8. It's okay. Now what about cyclobutane? Now we talk about cyclo here is in a ring. Butane, right? So this one is not just butane, it's called cyclo. If you look at cyclo here in a ring, 1, 2, 3, 4. It's okay, it's called cyclobutane. Now, cyclo means what in a ring? But means what? 4 carbon atom here. AN means what? There's no what? There's no double bond, right? So remember, carbon must have how many bonds? 4 bonds. So when you draw it like this, you need to add what? 2 hydrogen here. It's okay. Make carbon to be 4. Same here. 4 bonds. 4 bonds. 4 bonds. Right? If you check it very well, here we have 4 what? 4 carbon. C4H. Right? How many hydrogen? 1, 2, 3, 4, 5, 6, 7, 8. It's okay. So now what type of isomerism? Now remember, this cannot be chain isomerism. Just because chain isomerism only occurs in what? In alkane. So it is not chain isomerism, not what chain what isomerism. Now, what about positional? When we talk about positional here, I told you that they have the same functional group. Just like we have the same functional group. It is what? It is not chain, it is not what? Position. The possible answer here is going to be functional group. It is what? Functional group isomerism. Functional what group are what isomerism. Now, what is functional group isomerism here? They have the same molecular formula but different functional group. The functional group here is what is an alkene. It's okay. Why the functional group here is called cycloalkene? Cycloalkene. They are not the same. Cycloalkene, sorry, cycloalkene. They are what? They are not the same. Hope you understand. So when you see this kind of compound or this kind of question in the exam, what comes to your mind is because they don't have the same, they are not alkane, they don't have the same functional group. So the answer is what? Functional group what? Isomerism. But they have different functional group. When two compounds have different functional group, it's called functional group what? Isomerism. Do you understand? So the answer is what? Is functional group isomerism. The answer is what? Is functional group what? Isomerism. Functional. It's okay. All this video is helpful. Please, if it is helpful, please give it a like. Now, more of this video will come your way, right? So please subscribe if you are not subscribed and give this video a like if this video is helpful. Please kindly share with your friends and your classmates. Share this video to a WhatsApp group so that other people can see this video and watch the video. Thanks for watching. See you in my next video.